Assalamualaikum and hi. So, my name is Azhar Mohammad Shamsudin. I am a student of subject wastewater treatment biological technology. So, today I am with my friends from group 8. May I present to you is Qayyum bin Karim and Syahir bin Hasnadi. So, we are going to present our assignment project on the wastewater treatment technology in textile industry. Right. So, for introduction, as we can see that wastewater treatment is actually a treatment that designed to convert used water from any process of a plant in order to discharge back to the environment. Not only that, the water being discharged can be used back to the system itself to reduce water supply, as well as being discharged all the way through the environment or the nature. So this is a very crucial process in any plan procedure in order to keep in check the quality of water being discharged from any industry or any company due to the Environment Quality Act 1974 being regulated by Department of Environment DOE. So most of the industry in Malaysia or in the worldwide uses chemical in their manufacturing process. So with this, many chemicals being introduced to the effluent itself, making that the water can or may possess any toxic chemical which can be harmful to environment or any living creature. So this is why the EQA 1974 has been regulated by DOE. So in uh, during the decade, many type of wastewater treatment has been introduced, such as precipitation, flocculation and coagulation, aerobic and aerobic, and so on. The technology development has come to various type of process, which also involve microbes and the traditional methods. So, textile industry is one of the industry that uses huge amount of water in their processing plant. So, with with a lot of amount of water being used for the process, meaning to say a lot of water is being contaminated by the chemical being used for the chemical process to be proceeded. And this in textile industry itself, uh, being stated by Mira Liana, the journal I found about textile industry, approximately about 500 ton of 500 liter of water being used in a process monthly. So this is quite a huge amount. Uh, the 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 contaminant inside the dye or the process itself uh, can give the effluent of textile water industry become aesthetically undesired due to the color process being used. So next, I'm going to show the characteristic of textile wastewater, which is the left one is the characteristic or the quality of the textile effluent being untreated. So as we can see, compared to the right side, right table, which is the discharge effluent condition to be able to being discharged to the environment. As you can see that during the comparison, some of the parameters actually comply, but most of the parameter does not comply, which mean that this untreated textile water cannot be discharged to the environment. It can be used back to the process, but due to the dye contained in the effluent itself, the color tend to be changing uh, with the type of dye contained in the water. So, in order for them to use it back, you need to turn the color into colorless back for the color to be maintained in the process. So next we are going to talk about the technology involved. With that, I'm passing to my friends to continue my part.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Qayyum bin Karim. I will explain about the detailed explanation of the wastewater treatment technology that used in the textile industry. Many pollutants removal technological processes have been developed in the past decade to treat the textile wastewater. The treatment processes are being chosen on the basis of composition, characteristics, and the concentration of material present in the effluent. These processes are pre-treatment or preliminary, primary or psychochemical, secondary, tertiary treatment or combined treatment processes depending on type, sequence, and method of removal of the harmful and unacceptable constituents. Biochemical treatment methods are discussed as the process removes dissolved matter in a way similar to the self-depuration but in a further and more efficient way than clarifloculation. The removal efficiency depends upon the ratio between organic load and the biomass present in the oxidation tank, its temperature, and oxygen concentration. The biomass concentration can increase by aeration, the suspension effect, but it is important not to reach a mixing energy that can destroy the flux because it can inhibit the following settling. Normally, the biomass concentration range between 2,500 to 4,500 mg per liter. Meanwhile, oxygen about 2 mg per liter. With aeration time till 24 hours, the oxygen demand can be reduced till 99%. According to the different oxygen demand, biological treatment methods can be divided into aerobic and anaerobic treatment. Because of high efficiency and wide application of the aerobic biological treatment, it naturally becomes the mainstream of biological treatment. In textile industry, sequencing batch reactor (SBR) activated slash process are the most chosen wastewater treatment technologies. A typical process flow cinematic for a municipal wastewater treatment plant using an SBR is shown in the slide. Influent wastewater generally passes through screens and grid removal prior to the SBR. The wastewater then enter a partially filled reactor containing biomass which is estimated to the wastewater constituent during preceding cycles. Once the reactor is full, it behaves like a conventional activated sludge system, but without a continuous influent or effluent flow. The aeration and mixing are discontinued after the biological reaction are complete. The biomass settles and the treatment supernatant is removed. Excess biomass is wasted at any time during the cycle. Frequent wasting result in holding the mass ratio of influent substrate to biomass nearly constant from cycle to cycle. Continuous flow system hold the mass ratio of influent substrate to biomass constant by adjusting return activated sludge flow rates continually as influent flow rate. Characteristic and settling tank underflow concentration vary. After the SBR, the batch of wastewater may flow to an equalization basin where the wastewater flow rate to additional unit process can be controlled at a determined rate. In some cases, the wastewater is filtered to remove additional solids and the disinfected. SBR process is a reform process from activated sludge, which is a new operating mode. Its operation is mainly composed of 5 processes, which are inflow, reaction, sedimentation, outflow, and standby. SBR treatment process not only has a high removal rate of COD, but also has a high removal efficiency of color. Compared to the traditional methods, using SBR process has the following advantages. Next slide, please. The advantages for SBR is it has a great resistance to shock loading. The reserve water can effectively resist the impact of water and organic matter. Next is flexible control. The runtime, the total residence time, and gas supply of each stage can be adjusted according to the quantity of inflow or outflow. Next is the activated sludge has good traits and low sludge production rate. Since the original water contain many organic matter, which is suitable for the bacteria to grow, the sludge is in good characters. In the standby period, the sludge is in the endogenous respiration phase, so the sludge yield is low. Lastly is it has less processing equipment, simple structure, and it is easy to be operated. That's all from me about the SBR treatment technologies. I will pass next to the my team members to conclude the study. That's all.
For conclusion, the value of water resource is universally recognized, and the quality of life depends on the ability to manage available water in greater interest of the people. The process of production of textile, especially wet treatment and finishing process of textile materials, are huge consumer of water high quality. As a result of these various processes, considerable amount of polluted water are released. Joint efforts are needed by water technologists and textile industry experts to reduce water consumption in the industry. While the user industry should try to optimize water consumption, water technologists should adopt an integrated approach to treat and recycle water in the industry. End-of-pipe technologies are used for wastewater treatment and include sequential application of set of methods such as coagulation, flocculation, flotation, adsorption, evaporation, oxidation, combustion, and use of membranes that has been adapted to particular situation of a textile plant. As a result of the extreme variety of textile processes and products, it is impossible to develop a realistic concept of effective treatment of wastewater without detailed analysis of actual situation in the textile plant. Characterization of textile process effluent streams is very important to develop strategies for water treatment and reuse. To optimize treatment and reuse possibilities, textile industry waste stream should be principally considered separately. When the characteristics of the separate streams are known, it can be decided which streams may be combined to improve treatability and increase reuse options. It is important to explore all aspects of reducing emission and waste product from textile industry because it will result not only improved environmental performance but also in substantial saving on individual textile company. That is all from conclusion. With this, for my group, thank you for listening for our presentation.